Hello and welcome back to my keyboard integration series. In the last several videos we were following a keypad scanning technique which seemed to work perfectly fine. Even when multitasking it still worked, but however there was a big flaw somewhere and I could never figure that out. I could sit there and the keys were scanning just fine, but after exactly 30 different, key combinations, the microcontroller would just halt all on its own every single time. And I tried many different ways of trying to resolve that problem. And finally, I just pretty much had to give up. And in this video, we're going to learn a new scanning technique. But that's not to say that we didn't learn something from the last three videos. We learned how to multiplex, and we learned how to add these transistors to brighten up our 7-segment displays. We learned how to store, whatever was pushed on the first key so that we can put it in the second key or in the second 7-segment display. So we've learned a lot that will help us, move a lot faster with the next few videos. Here I'm at 1D, and if I press the second key, boom, the microcontroller halts. So we're going to have to toss all this away and start a new method. Okay, here's our new one. Oh, I forgot to introduce you. As I kept having to pull these microcontrollers in and out of the breadboard, I ended up bending a couple of their pins. So I picked up a couple of ZIF sockets so that I can just easily take them out and put them back in and just, lock them down and not bend any more pins. Oh, let's do a reset on this one. This is the new code, and we're going to be starting from scratch. Right now we have it, hooked to the common anode connected to a resistor and straight to the 5-volt rail. So that's why they're so bright, but you can see the scanning technique works. So let's go take a look at this new code that we're going to start using. Okay, here's our new code. Now it might look complicated only because I added, detailed notes on pretty much every instruction. It is actually kind of short and sweet here. It just, all the notes add to it. So let's just get started. Up here at the top, we're moving 0FF into P3 to set P3 as an input port. We're actually going to be using 2 ports for scanning here. P3 for the columns and P1 for the rows. So the next command here we have move P0 40H, which means we're going to store the 7-segment code for a 0 on the output port, which is P0. So when we start our program, it's going to start at 0. Okay, here we have K1 and K2, and all they are used for is to test to see if any key was pressed at all. So we start off by moving P1 with 0, 0, which at first I thought, why would we be doing that? Doesn't P1 need to be, all ones, and then we just one port at a time turn it on? Yes, that is correct. However, in these two, this part of this program, all we're doing is trying to find out if any of the keys are pressed on any of the rows. So we're turning all the rows to 0, and if a key is pressed on any one of those rows, it's going to show up. So we're grounding all the rows on P1 so that any key pressed will show up on P3 on the P3 columns. Now we're going to move P3 into A to read all the columns, and now we're going to AND that with 0F or 0001111B in binary. So we're going to logically AND or mask the bits of the P3 columns with 0F to see if any of the keys were pressed on that row. Now we're using binary here because it's like a visual aid. You can tell which bits are being set to a 1 and which ones we really don't care about, like these over here. That's why they're all zeros. On the columns, so right here we're going to jump, or we're going to compare and jump, if not equal, to K2. So if there is a 0F still on the columns or on P3, we're just going to jump right back up here to K1. But if there is still something showing up on the columns row here, say one of these bits actually shows up as a 0, then we'll jump down to K2. In K2, we're basically just doing the exact same thing. We read all the columns, we AND it with 0F. We're just double checking. And then we compare, again, P3 with 0F. And if there's still something there, we're going to go down here to check R. If data on P3 other than 0F, jump to check R to find out which row. Now we're setting back. Now you can see we're moving into P1 a 111, 1110. So only one of the bits is low. All the rest have been set high. So set all bits high on P1 and set P1.0 low to examine the rows. Then we're going to load P3 up into A and do pretty much the same thing, except now we only have one bit on P1 that is low. So only if that row, if P3 shows something is actually, on that row, will, the AND 0F have any effect. So we're going to AND again with 0F to see if any keys in row 0 were pressed. And jump if not equal. If it's not equal to 0F, we're going to jump down to a subroutine called row 0. And as we go down here, you can see all we did, the only thing different here is we set the next bit low to see if something gets pressed on row 1, and we would jump down to row 1. Then we just set this bit low on P1 and check row 2, and then finally we change this bit to find out if there's anything on row 3. Now all these row subroutines are very short and sweet. All they do is change the data table that we're going to use. So move DPTR to K-code 0, which means we're moving the data pointer to row 0 table called code 0. And then we would jump to find out which key is actually pressed on this row 0. The same with row 1, we're just pointing the data pointer to the code 1 table, and here to the code 2 table, and here to the code 3 table. But we're always going to go to find once we've already pointed our data pointer to the correct table. So right here's find, which is a nice short little subroutine, and all it does is it rotates right with carry the contents of A. Well, we have P3, the contents of P3 on A, so we're going to rotate that right to find out which bit is now set to a 0. So we rotate right with carry P3 columns until there is no carry. So if it's a 1, it's going to be a carry, and it's going to come down here and increment the data pointer and jump back up here and rotate right again with carry until it finds a match, which if carry equals a 0, it goes to the first byte of the data pointer, or it increments data pointer until carry is 0. So either we're going to increment it or we're going to jump straight to match. Either way, we're going to jump to match once we find out which column has the key pressed on it. So down here at match is where we're actually going to display which key was pressed. So the first thing you do is you're going to clear A, which that sounded a little weird to me too. I mean, if we're going to move C, A, and at A plus data pointer, really all we're looking is at the data pointer, and we're loading the correct data pointer since it was incremented to A. So we want to clear A to make sure it doesn't, interfere with the data pointer at all. We just want the correct data pointer with the correct data to go into A. And once that is into A, we're going to display it right on the output port of P0 and then start the program all over. Of course, we have this small delay here, and here's our different tables. This is for the first row. We have 79, which is a 1, 24, which is a 2, 30, which is a 3, and 0, 8, which is an A. And for the second row, the third row, and the fourth row, it's the same thing. So this is a pretty simple program to understand. You can change all these binary numbers to hex numbers, once you become familiar with it. It's only in binary right now so that you can see which bits on the port 3 are going to be set high, and that we're going to end up rotating during the fine portion to find out which one of these bits gets changed to a 0. And of course, we're going to find out which row it was by incrementing the rows one at a time. Here we have this row, there we have this row, there we have that row, and there we have that row. And it's a pretty simple program. So let's move quickly on to the next step, which is multitask or multiplexing this display. Again, since we've seen the other videos on multiplexing, we can simply make a few changes. Well, to multiplex, obviously, we're going to have to add a few a second segment display. So this match is going to have to change. We can't just simply send it out on P0. We're going to have to store this and have a match 2. We'll store this one. We'll let's see. We'll store this one probably on R1, and then for the second data point, or for the second 7-segment display during match 1, we'll set that to 0 by putting 7-segment code 40 out on R2, but they won't be displayed until it goes up to the multiplexing section of the code. So let's take a quick look over here to the next step in our program. Now here we start with, again, we load P3 with an FF to set it as an input port. Now we're going to set R1 with a 0, 1, because we're going to use that as a counter to tell if it's the first key press that needs to go into the first 7-segment display, or if it's the second key press that needs to go into the second 7-segment display. R1 we're going to start with a 0, R2 we're going to start with a 0, and here we go. We began by moving R4 with a 10. This is basically so we can repeat this multiplexing thing several times to act as a delay and to make sure our numbers show up well, and it's not just when the key's getting pressed, it's not interfering. So this goes around several times, and then it'll go through this quick key checking thing real quick and back up to multiplexing the display so that there's no time loss. So again, with multiplexing, it's pretty much the same thing. We're using P2 as the control signals. So we're making sure P2 is clear first, and then we're setting P2.0 high, and we're going to call R1 once there's some data in there. Right now it's just a 40, so we're going to put that 40 out on P0 and then call our delay. And multi-2, the same thing. We're going to clear all the bits on P2. Now we're going to set P2.1 high and move the contents of R2 out on P0, our output port. And of course, we have that set as a 42. So we'll have 2 zeros to start off. We'll call the delay, and we'll keep doing this multiplexing for several times until, you know, R4 becomes 0. Then we'll go down real quick and start scanning the keys. And we've already gone over all of this, how to check the rows, and the row, you know, selecting the correct row table here, doing the find, rotating the 4 bits over until you find out which one of the keys was pressed in that column, and jumping down the match where we start our display process. So now that's changed a little bit. We're going to check R0 to see if we're on match or match 2, if we need to display the first key pressed, or display the second key pressed. Well, let's say right now we're still on the first key that needs to be pressed. Again, we're clearing A. We're going to take that data pointer and store it into A. So now we have the contents of the correct table going into A, and we're going to store that into R1. And when the first key is pressed, we're going to store a 0 back into R2. Call a quick delay, jump back to the beginning. Then we're going to come down here. Now the second key has been pressed. We're going to move R1, which was stored up here, and we're going to move that into A, and then we're going to move that over to R2. So that first key that was pressed is now going to be stored in R2. Now we're going to clear A again, get our data pointer for the first 7-segment display, and store that back into R1. The new key press is going to go into R1. Then we're going to reset our counter so that we go back to the first key on the next one, call a delay, and jump back to begin. And again, go over the multiplexing. The first key pressed is now going to be on R1. It's going to show up here on P0, and the second key that's stored in R2 is going to be pushed out on our output port P0 as well, but during its multiplexing phase when set bit P2.1 is high. Okay, well, let me wire up this breadboard so that we can see this code being multiplexed. Okay, I've rewired everything, and as you can see, I also added my transistors in here to drive the bases. So we're all ready to multiplex here. Everything's coming out of port 0, going to both displays. I got my 2 control lines here, go into my transistors so that we can drive the 2 7-segment displays properly. So let's go ahead and power this on and take a look. Do a reset. As you can see, we're starting off both displays with that 0, and now we're multiplexing. Whoops. You can see as I press the first key, we get a 0 back in that second 7-segment display. That's so that we know when we're pressing a first key. Unless, of course, you're pressing a 0, then you might not know, but for everything else, here's a 0, 0F. But I've also tested this and, you know, pressed the keys a lot, and the processor doesn't halt after, you know, 60 keys have been pressed, or 30 2-digit hex numbers have been pressed. So we'll be able to move this over to the big board and start counting how many times, you know, we actually enter a complete set of two numbers. So that will be on the next video. Thanks for watching. Have a good day.